operating system and application deployment with Puppet and Razor. Enjoy.
Thank you. Good afternoon, everyone. On? Oh, even better. There we go. So I know I'm the one keeping you from all the beer afterwards that is being sponsored by GitHub. So I'll try to make this as interesting as possible. My name is Jonas Rosland. I work as a software-defined specialist. And before I dive into my talk, I would like to ask you here, because we've been doing hand raising all day, so we'll continue with that as well. It's good for some exercise as well. So how many here have heard about Razor before? Oh, nice. That's a lot of people. How many here have been using Razor or are using it? Not that many. Okay. I hope I can change that because Razor is a really cool tool. Just to let you know as well, I'll be doing a live demo at the end of my presentation. And that live demo, some of it is dependent on the Wi-Fi connection. So if you can all please shut down your torrent clients while I do that, that would be very, very nice of you. So I work as a software-defined specialist at EMC, and in my role, I focus on everything that has to do with the software-defined data center. And we've heard a lot about the software-defined data center today, and how you can use Puppet in focusing on some of the aspects of the software-defined data center. And because we see the software-defined data center as the core technology that you need to master to be able to take yourself up above the clouds. So this is me jumping out of an airplane, actually going down through the clouds, but of course we want you to go up as well. So today I'll be showing you how you can utilize Razor as a provisioning tool. We heard this morning about Razor not being production ready, and that is true because there are changes being done to Razor, I would say daily right now. And that is because there are so many intelligent and really smart people working on it to make it a really good tool. We've also heard a session about Foreman, which you also can use to provision your operating systems if you want. So this is another subset of tools that you can utilize. So Razor is a tool that was created, let's see, it was created by us, EMC, and Puppet Labs together. It was released in May last year, and it's been actually been deployed in full production at a few customers, there we go, at a few customers over in the US. So it's in production, and it's really, really cool, and I'll show you why it's cool. So the Razor is a cloud provisioning tool, and what's really nice about it is that you can provision both physical and virtual machines. We don't really care about what type of virtualization engine you're using because we're not really talking to that virtualization engine. So if you want to deploy on an IBM Blade, a physical Dell server, maybe a VMware virtual machine, a Hyper-V machine, SEN, KVM, full OpenStack environment, you name it, doesn't really matter because Razor can deploy on both. And it can also deploy not just operating systems, but also the hypervisors themselves. So looking at VMware, so VMware ESX, we can deploy that. We can also deploy SEN servers immediately. And of course, with Puppet's help, we can also deploy an entire OpenStack environment using Razor and Puppet together. So with this, you can not just do operating system deployment, but rather the entire server infrastructure that you need. Another cool thing about this is that it's also event-driven instead of user-driven. So what that means is that I do not choose where to install my server. So let's say you create a virtual machine, you choose the operating system, you choose the all the settings and so on throughout the installation of an operating system. We don't do that here at all. because everything's event-driven. And it's event-driven using certain models and policies that we build up in the Razor tool. What that means is that you just boot up your servers, be it virtual or physical. I don't care. Just push the power button and then walk away. You do not have to choose the operating system, or if it's an hypervisor, we can deploy everything using an event-driven model. Sounds cool? Yes, is the answer. Good. So one of the questions I get, and I think you get this as well if you're using other provisioning tools, why not just use templates? Well, templates, especially in a VMware or a virtual environment, I would say, templates get old really, really fast. I used to be a consultant, a VMware consultant for 5 years almost, and I saw the templates that they were using, they were getting old about a month after they were created. So you had to do a lot of manual maintenance to actually have those templates up to date all the time. Of course, it's also harder to maintain them because they are pre-packaged, and you might not really know exactly what is going on in there. You might have updated some part, but not the other. And looking at a Linux environment, it's not easy to just upgrade a virtual machine or so to the next distro version using a clean install or something like that. But we can do that with Razor. So how does it work? I'm going to show you how it works, and then I'll show you a kind of a manifest on how to use it with Puppet, how you can manage it with Puppet, and then I'll show you a live demo of how it works as well. So Razor has something that is called an auto-discovered real-time inventory data. Long, nice sentence there. What that means is that we get all the information about a virtual or physical server immediately when it boots up. So the server boots up, it's a regular PXE boot after that, and we boot something that is called a microkernel. That microkernel includes Factor. Factor, which has been a bit customized, that Factor reports back to the Razor server everything about that specific server that was booted up. So we can see the manufacturer, Dell, IBM, VMware VM. We can see the amount of memory, we can see the number of CPUs, we can see the MAC addresses they have on the network cards, we can see everything that you can get out of Factor. So all that inventory data is very, very important because we can use that in creating our models afterwards. This is also to eliminate manual tasks in actually checking what the specific hardware of that virtual machine or physical machine actually consists of. When we have all those facts, let's say it's a physical Dell server with 2 CPUs and 4 gig of RAM. Can you even get a server right now with 4 gig of RAM? Maybe it's a virtual machine then. So it's a virtual machine with 2 CPUs and 4 gig of RAM. It boots up, reports back to the Razor server with those facts. The Razor server says, okay, I actually have a model and a policy that would apply to a physical hardware setup that is configured that way. 2 CPUs, 4 gig of RAM. And we can automatically, dynamically select the image that we want to install on that specific node. So you don't have to push any buttons, you don't have to enter any host names, you don't have to enter any root passwords or anything like that. It will automatically provision the server no matter where it is. So using the information that we get from Factor and then the dynamic image selection, we also create something that is called a model. That model consists of some information that is important for the operating system to know when you provision it. So looking at a Debian or CentOS installation, it would be host name, maybe domain name, and root password. That's pretty much it. For an ESX host, there's a lot more going on. You need passwords, you need gateways, you need IP addresses, you need everything. So everything that is needed for the operating system or the hypervisor to get installed is defined in the model. So we create a model that defines how we want our operating system to look when it's done provisioning. So this model is also being used during the provisioning because we can actually follow where, we can actually see where it is in the provisioning steps. So you'll see later on, I'll boot up a VM, and you will see it will be initializing, then it will be pre-installing. We will see some post-installation facts, and after that, we will also hand it over to Puppet to actually do some real work. Because empty VMs without no services, or without any services, just an empty OS, not that exciting. So we point them directly to the Puppet master that we have. Razor is a totally open source framework or totally open source tool that you can use. And because of the openness of it, it also has a fully open API. So it's a REST-based API that you can use. So you don't have to use the CLI that I'll be using. You can create whatever you want, what type of management tool that you want, or utilize an already existing tool that you have that speaks REST. So it's really easy to have full programmatic control of all the provisioning inside your private data center or private cloud, if you want to call it like that. So in the end, this gives us a metal to cloud deployment model. So from bare metal or virtual metal, if you want to call it that, to a cloud-driven operating model. So it's really easy to get started with as well. I first got news of this, even though I work at EMC, I had no idea we were working on it until it was released at the end of May last year, so soon 1 year ago. I had no idea, but I sat down last summer, grabbed a glass of wine, had a really nice coding session, lit some candles. It was beautiful. And after that night, me and Razor, we were like best friends. So it's really easy to get started with. And I would highly recommend you just go and download it and start using it. So I'll show you here how we can combine Razor and Puppet to make it an even better symbiose. So looking at hold on, I need some water. Looking at an installation and a full management of Razor can be done by using the Puppet Labs Razor module that is available on the Forge. Have you all seen that one? No? Okay, it's there. So just download the module and then you can do this. Very, very easy. Just include Razor. That's it. I need to have a config file replaced there for sudo, but that's just a kind of a workaround. So that's all you need to deploy Razor. Nothing special, right? You're used to this already. So when we look at how we manage this, first of all, I want to add something that is called a broker. The broker in Razor's language, the broker is what we leave the operating system to after we're done provisioning it. So it could be a Puppet master, it could be Chef, it could be vCenter for a VMware environment. So it automatically joins the VMware cluster, or a Zen cluster for that matter as well. So here I've created a broker. I call it the Puppet broker. I'm using the plugin Puppet. You'd use another plugin for another broker as well. And you can define some metadata here. You can see I'm using a really old version of Puppet, 2.7.18. I should really upgrade any time now, any day now. And I also define the server that I want to point it to. So this is my lab. I have a blog at purevirtual.eu where I have a bunch of how-tos on how to get started with Razor and Puppet. So this is my lab environment, purevirtual.lab. I'll put up some links later on as well. So when I've created a broker, something to leave it off to, I also need to add an image that I want to deploy. So this is how I add an image. I create an image that I call Ubuntu Precise. It's of the type OS. It's not a hypervisor, because that would be different. I put in a version number there and a source. And you see I'm using an external source. So this makes Razor actually go download that source immediately for me, so I don't have to do that myself and import it. It will automatically see if there are any changes, then it will download it again. So when I have an image, I can create a model. So this is how the model looks. I have a model called install Ubuntu Precise. I am using the image that I've already defined, and then I put in some metadata such as domain name, host name prefix, and my very, very secret root password. That's all there is to it. You can see down here also that we have a template that is called Ubuntu Precise. So Razor right now has support for SUSE, Ubuntu, of course, Debian, CentOS, Red Hat Enterprise Linux, Sun servers, I think there are some more, VMware, of course. Microsoft support, Microsoft Windows support is coming, but it's taking a bit longer than expected. So what we do now, when we have the broker, we have the image, we have the model, is that we create something called a policy to bind it all together. So this is the final piece of the puzzle. So I create a policy where I assign a broker that I want to connect to. I assign the model that includes the image, and I use something called a tag to define which servers, virtual or physical, that will be installed using this policy. This is where the event-driven functionality comes in. So instead of having mem size 1 gig there, I could put 2 CPUs and 4 gig of RAM, install this one. If you have a VMware ESX host, maybe a nice Cisco Blade chassis or something like that, with 192 gig of RAM and 32 cores, well, you put that into that policy, 32 cores, 192 gig, install ESX. All you need to do is boot up the servers. That's it. You want to see a demo? Yes. Good. So first I'll show you some nice code here. Don't bash me on how it looks. So I'll show you the code that I've been using. It's the same code that you saw in the PowerPoint, so it's exactly the same code. I've installed Razor here. I'm using DNS mask as a kind of an easy DNS and DHCP server. That is totally optional. I've created a broker with a Puppet broker there. I've created an image, a model, and a policy. So this is the entirety of the code that is needed to deploy Ubuntu hundreds of thousands of times, if you want. So that's just one policy. Of course, we can have more. So I have one for Ubuntu Quantal as well, 12.10. So I have another image. I kind of have the same model, but using another image, and I have another policy as well. Of course, I can have some other operating systems or distros as well. So I have a CentOS 6.3, another image, another model, and another policy. So you can see here that the policies are a bit different. So looking at this one, you can see the tag has is set to mem size 2 gig. You can see this. But looking at the Ubuntu one, it's mem size 1 gig. So if I boot up a server with 1 gig of RAM, that will install Ubuntu. A server with 2 gig of RAM will install CentOS. Okay? So let's see if this works. So I'm going to create a new VM here, without disk, of course, because we're going to do a network boot. And it's a CentOS, that's fine. Customize a bit. How much RAM did I need for a CentOS? 2 gig of RAM, okay. Let's put that in there. And I'll put it on my network as well. There we go. Perfect. And there we go, good. So what you see here is a regular Pixie boot, and it automatically boots up this microkernel that I was talking about. So this microkernel contains a modified factor that gives out even more hardware facts than usual. So what it does here, it's booting up that microkernel, gathering all those facts, and then reporting back to the Razor server. And it will look something like this. Let's do this. So you can see I have a Razor node already here. Last checked in 230 minutes ago. That was my last attempt today. Tried it out to see if it worked. Let's see if we can get another one here. Perfect. We have a new node that have come up. That is the new server that we just created. You can see here it has a unique ID. It checked in 10 seconds ago. The status of this is bound because it's bound to a policy due to the fact that it's actually, there we go, it's actually matching the mem size 2 gig that we set in our policy. So within Razor, we have a few commands, and all these commands are, of course, available using the REST API as well. So we have another one that is called active model, where we can look at the provisioning process, how far it's come. And you can see here that we have a policy, the CentOS 6.3 policy, the node unique ID, which is the same as the node ID. You can see it's initializing right now, and soon it will move into a pre-install phase. It will attach itself to the Puppet broker that we have defined. This is the 11th server that I will be deploying using this particular policy. It's pretty easy. So let's see how it looks. Okay, something's happening here. It's rebooted. It's right now booting up the CentOS installation, and it will start installing CentOS using the model that I created, so the root password, the host name, and the domain name. Of course, we have more settings as well because we need some more, and those are just regular kickstart or pre-seed files that we have as template. So you saw we had a Ubuntu Precise template. Of course, you can create another template using another kickstart or a pre-seed file to match whatever your installation should be like. So the CentOS installer is running here now. We should see something here. Okay, init, good. We can also look at the log view here, and you can see that we're starting a Red Hat model install. Well, CentOS, Red Hat, pretty much same thing. And we have sent it a kickstart file. So we can see that it succeeded in sending the kickstart file over to the provisioning machines. We can actually follow it and see how far it's come. No. And empty. Yes. Perfect. Continue. There we go. So it's booting, and we'll continue installing there now. And after it's installed, it will leave it off to the Puppet broker. So I'll show you what I've done more here in the code that I have. So this is just the Razor part of it, right? And you can see here in the CentOS model, I've set a hostname prefix to CentOS dash the number of kind of the following number that of how many nodes have been provisioned using that policy. So this host will be CentOS-11. I've also created a very rudimentary Puppet manifest for my nodes here as well. So using, if I booted up Ubuntu, I would use my own module. You can look it up on the forge. It's not beautiful, but it's there, for Lighty. But since this is a CentOS machine and we're handing it over to the broker, of course, we will install WordPress and opening up a firewall port. So this will all be automated. And remember, I haven't really touched anything, right? I just pressed power on. So I haven't defined anything on that particular node, but rather I'm using policy-driven and event-driven mechanisms to actually make this happen. So while this is booting up and restarting and then installing, I can take some questions. Yes?
So you can basically just decide the policies based on the hardware, or can you also change and other custom facts or tags or whatever?
So any custom facts that you can implement in the factor that is included in the microkernel, you can use that. So it's a regular custom fact in factor. So looking at the nodes, I'll show you here. Let's take that one.
Can you please repeat the question?
Oh yeah, sorry. So the question was, can you set the policies on any other attributes than the ones that are automatically assigned to it? Yes, of course, you can extend the factor that is in the microkernel itself. So the microkernel is an open source project by itself, so you can do whatever you want there.
So you have to have multiple microkernels for installer for creating different policies.
So you don't need to. It depends on what you. The question was, do you need several different microkernels for different policies? You can have one microkernel that includes all the facts that you need for your entire infrastructure, if you want. It's not that it's going to be humongous and really large, because factor is so small anyway. So all the facts that we can get out, we can look at them now as well. So these are stored in the Razor database. And you can see all the hardware facts that I got out of this virtual machine. You can see the IP address that was assigned to it using DHCP. You can see the fully qualified domain name. This is just a MAC address, my domain name. And you can see the MAC address, you can see the manufacturer, and we can see that it's virtual using VMware. Now you can see it's moved into the post-install phase. So right now, it's actually most probably booted up already. Yeah, okay, soon. And using in the post-install phase, it will inject Puppet, install Puppet on it, and push it onto the Puppet master. Yes, question?
If I have a node, a little machine maybe, and I want to give it 1 gigabyte RAM, there's the possibility to select during startup. You have 3 images, all are possible due to the tabs. Is it possible to say, okay, I select number 1, Ubuntu, or what else?
Okay, so what you would like is a kind of a boot menu if you have several machines that have the same hardware types. So looking at your question was, can you have like a choice of operating system installations if you have a machine with, say, 1 gig of RAM?
Yeah, if I have 3 images, which will be okay for this type of hardware,
Yeah.
that I can select it, because it's not a very good idea to say, okay, this little machine or this image needs 1 gig and 100 megabyte to select another user.
So usually what we do is that we use some of the other attributes here that we can get from factors, such as the MAC address. Because we know that that host will then be, or that node, depending on what you're running, that node will be installed using the particular policy that we want to apply to it. So you can use the MAC address as a tag as well. So it's pretty easy to do that. So I have that in my code here that you can see. So right here, I have 2 tags for a Hadoop cluster. So I've said if this key is equal to this MAC address, then the tag MAC Ethernet 0 of the name node will be applied to that specific node. So here you can use MAC addresses, which is pretty easy if you're using kind of an orchestration tool. When you create the virtual hardware, you will know the MAC address, and you can easily take that and inject it into Razor and have that install everything for you. Yes, question?
Can you define a static IPs?
Sorry?
Can you define static IP addresses in this code?
Yeah, so the question is, can you assign static IP addresses? Yes, of course you can. So the models that I'm using here, the Ubuntu and CentOS models, they are DHCP based. But if you create a model like the VMware model, they only use static IPs. So you can define, you can create new models, and you can define static IPs if you want.
Can you chain together multiple brokers?
Sorry, once again.
Yeah, can you chain together multiple brokers? Like, let's say I have a multi-stage bare metal provisioning process where I need to do some amount of burn-in testing and RAID partitioning and whatnot, and all those are going to happen in discrete phases. Like, can you chain those together so that whole life cycle is automated, or do you really only have option for boot up provision?
Yeah, so the question was, can you kind of chain load different parts of the provisioning process to hand off to different brokers in different situations, right? Right now, Razor is only focused on provisioning and then handing off to a broker. What that broker then does is entirely up to your configuration. So we also have a broker that is just a script. So that script can do anything that you want. That script can also maybe set up a RAID properly, maybe install some packages, pull down Puppet, automatically verifies certificates, sign certificates, and do stuff like that. So it's all up to the broker, because Razor does not take care of that. No. Yes?
If you interrupt the installation, Razor detect that the installation was interrupted and...
Yes. So the question is, can you detect if an installation failed or was interrupted? And yes, you can. So Razor detects that it was interrupted because it doesn't get any answers from the server anymore, meaning it will say broker failure or post-install failure or pre-install failure, depending on where in the process it was. So I'm just going to look at this. Perfect. We can see we have a broker success. Just want to log in and show you what happened here. Can you remember my password? Password, good. So we can see now that I have MySQL installed using Puppet and an HTTPD server as well, and that is now serving up my WordPress blog. So all automatic, I didn't even touch it, I just booted it up, and it got installed and provisioned, and the software is installed as well. Pretty cool. Question over there.
So the server needs to be configured to boot from PC every time?
So yeah, that's usually the way I do it. Because what we can do then is that we can reconfigure the machines when we don't need them anymore. So if they always PXE boot, it means that they will always check in with the Razor server. They do not always boot the microkernel though, because it checks in with Razor during the pre-boot phase. It checks in with Razor and says, here I am, I have this unique ID, have I already been provisioned? And Razor says, yes, please go on and do local boot. So what we can do, if I don't want this CentOS machine anymore, I can just remove the active model and reboot it and reinstall it with whatever I want. So PXE boot all the time.
Does your microcode have effects which provide access to firmware text?
So your question is, does the factor in the microkernel get firmware texts? Tags.
So it's possible to tag the virtual machine as a class of Ubuntu or else operating system and to determine it inside the microcode.
That's a really good question. So right now, I don't think that's in the factor. I don't know, can you do that with factor at all? Anyone else more versed in factor than I am?
The microcode has a Finder tools installed, maybe?
Yeah. So it's all up to you how you want to utilize factor, because it's a standard factor, it's just a customized version of it. Yeah. More questions? Yes.
How do you resize RAM if you want to?
Good question. So how do you resize RAM? Well, you can do that, sure. You can just reconfigure the policy as well.
Okay.
So you can just update it, saying now this policy is for all machines that have 8 gig of RAM. So then you can just reconfigure your servers with 8 gig of RAM and done.
So you do a new provision or?
No, you don't have to, because it's already tied to a specific policy. So when you reboot it, it will say, no, go ahead, do local boot. Question behind in the back?
Is it possible to use something like on machines with more than 2 gigabyte RAM? Or between 2 and 100 gigabyte RAM?
So there is a, you can use some ranges. Right now they are regex ranges. So I would say yeah. Had some questions over here, I think? No? Okay. Yes, there we go.
If I understood correctly, the new machine was connected to the master as an agent.
Yeah.
How does the signing process?
Well, you know, because I'm very security conscious about my security, this is how I've configured it. There we go. No, there we go. This is my autosign.conf. Very secure, perfect. So it works great for our demo. Of course, you probably could use something else. Because if I do not have this in there, it will end up with a broker failure, meaning Puppet installed, but I can't do a Puppet run because I'm not allowed to talk to the Puppet master. So it will always fail. So I do this for demo purposes, and of course you can do that in your private environment as well. Yes?
How does Razer calculate the unique ID? So if you upgrade the RAM, the memory of the machine,
Yeah.
and afterwards you match another rule, your live machine becomes new installation.
So the way it creates the unique ID is based on different factors. I don't remember which ones, but I don't think it's memory based. I think it's more based on the MAC address, for instance. But if you change the MAC address, well, you can update the node as well. Well, not really, but yeah. Question in the back there.
What if multiple contradicting tags match?
So if you have contradicting tags, like 2 different policies that have the same tags, is that what you mean?
No, but one was used for 1 gigabyte of RAM and one for subnet. And the one should install Ubuntu and the other one should install Camp NUE.
Yeah, great question. I don't think that's solved yet. So it's really easy to get started with. As I said, these are very, very basic tagging rules. Of course, in a real environment, you would have a plethora of different rule sets that you need to adhere to. So you would probably use something more than just one subnet and maybe a gig of RAM. And then you don't have that problem. But yeah, right now you can actually create conflicting ones. Something that is pretty cool with the Razer though is that when you look at the policies that we have, we can also set a max amount of nodes that should be deployed using this particular policy. You can see on the top there, you can see that we have maximum 10 nodes using the CentOS policy. Meaning, when I've deployed 10 CentOS nodes, no more servers will be deployed using that policy, even though they match the tags there. So you can have several policies using the same tags, just set a maximum on them, and you will kind of spread out your load. spread out your operating system deployments. Any more questions? So if you, there we go. So if you want to read up on this a bit, I've done a couple of blog posts on this. I did 5, I think, in July last year. They are good if you want to look at the workflow of working with Razor. Some of the commands there they don't work anymore though, because it's been updated since then. I have a few more recent posts that goes through the setup of Puppet and Razor together that I have here. I think it's 2 or 3 posts that you can read as well on purevirtual.eu. If you have any questions afterwards, I'm usually bombarded after these events with emails, so if you want to send some more, please do, or hit me up on Twitter. Thank you very much.
All right, thank you, Jonas.